Hey y'all, it's me, Miss B, and today we're talking about modeling exponential growth and decay. So, to start, we have these two equations that are similar, but slightly different. So, we've got A equals A sub 0, B to the T minus T naught, and we use this when we have two different times. And then we have this one where we have A equals A sub 0, B to the X, when we just have an X value that's given. So first of all, let's go through and say what these things are. First, I want to say that this is we call it a knot, just because that 0 kind of looks like a knot. So A, or Y sometimes, is the amount or population that our final there. A sub 0 is going to be the starting amount. B is the growth or decay factor. We'll talk more about that in a second. T is time, and T naught is our starting time. And again, we use these when we're comparing two times. And then X is going to be the number of times something happens or occurs. All right, and then exponential growth is going to be when B is greater than 1. And so here, if I have this B value right here is 9, therefore, and because 9 is greater than 1, it's growing. Okay, so for each exponential function below, we want to determine the initial amount and the growth rate B. So we're looking for A sub 0 and B. Here's my A sub 0. And then here is my B. A sub 0 is going to be equal to 4, and B is equal to 1.345. This next one here, we've got 5 and 1.1. So A sub 0 is equal to 4, and B is equal to 1.1. All right, go ahead and do this next one on your own. All right, this next one here, we've got bacteria in your mouth grows exponentially by a factor of 1.5 each hour. Suppose you have 10,000 bacteria in your mouth right now. How many bacteria will be in your mouth in 24 hours? So let's go ahead and we only have the amount of times that it happens, so we're going to use A sub 0 A equals A sub 0 times B to the X. And so I'm going to pick out my A sub 0, my B, and my X. So let me actually just make that. So A sub 0, B, and X. All right, so reading in here, it says it grows at a factor of 1.5. So that's kind of the dead giveaway that is going to be my B value, because it says a factor and it even says each hour. So that's going to be 1.5. Moving on, it says suppose you have 10,000 bacteria in your mouth right now. how many bacteria will be in your mouth in 24 hours? So that 10,000 is my initial amount. That's how many bacteria I have now, and then I want to know how many I have in the future by 24 hours. So it says each hour up here, so 24 is my x. So then it's just a plug and chug problem here. So I've got A equals 10,000 times B to the 24th. Okay, when I do this, I have to do this calculation first. Remember, by PEMDAS, exponents come first. Type that into your calculator, and you should get what? What should you get? I'm going to make you type that in there. All right, so you should get 168,341,122 bacteria. So we have 168,341,122 bacteria. Okay, and we are going to pause.